I've come to realize, researching and getting on top of things for this interview, we have a giant problem with microplastics right now. Not just in this country, but all over the world. Plastics are everywhere around us. They're doing things inside our bodies, altering us genetically, causing infertility in some cases. But there might be a solution to this, and the man behind a potential solution is sitting across from me this morning. He is Dr. Nick Monsool. Dr. Nick, how are you?
I'm very well, thank you. Thank you for having me here.
Let's just start with this, Dr. Nick. Microplastic concentrations in American brain tissue have increased by 50% between 2016 and 2024. Some of your research shows me.
Right.
You know it's a big problem. Can we talk about what studies are showing it's doing when it's inside our bodies right now?
So the study you're referring to was looking at brains. So people who have died, they looked at brain tissue, and I think the first study was in 2016, and they measured a concentration of plastics inside the brain in 2016. And so whatever it was, they did the same type of study in people who have died, and it took a look at the concentration in those brains just 8 years later, and the concentration of plastics in respective brains doubled over the course of about 8 years.
The major cause for that would be more plastics everywhere.
Increasing concentration of plastics. And there's a very interesting study that was just produced, I think in like Scientific American, looking at the volume of plastics produced per year. So this is the one where I just showed you. And in like 1950, the amount of plastics produced per year was roughly maybe 1 million metric tons per year. And then, you go 20 years later, and then it's increasing asymptotically. So went from 1 million metric tons 20 years later, now you're producing roughly 20 million metric tons, to the point where in 2020, they're producing, or the amount of plastics produced per year is roughly 200 million metric tons per year in 2020. And that's important because if you're 25 years old, you have been exposed to roughly 250 million metric tons of plastics in the world per year. So there's no way that it's not getting into you.
It's unavoidable.
It's unavoidable. It gets into you through your food. It gets into you from the just aspects of daily living, from the plastic spoons that we use.
How about your laundry detergent?
Laundry detergent. So it also is aerosolized, and you breathe it in. And it also gets through to your skin. So that's a huge absorptive surface.
Let's make people really care about this. What does it do, what negative things does it do to you when it's in your body?
Again, you need to be careful with that because no one is entirely sure, right? That's one of the projects for HHS and Secretary Kennedy is to understand just exactly what is it doing in the body. So,
well, I should say this: it's doing something.
Oh yeah, it doesn't belong there. That's for sure. Yeah. So for Secretary Kennedy and HHS and the STOMP program, so systematic targeting microplastics, trying to figure out what kind of plastics are getting into you, what size are they, where does it end up, how much does it take to actually start causing a problem, and then finally, specifically, what problems does it cause? So it's not just correlations like, hey, wait a minute, we found a lot of plastics in the coronary arteries. How do you actually prove that it's actually causing a problem? And that's where the science is still trying to catch up. But, one thing is abundantly clear. It just doesn't belong there. You take a look at, plastics inside the placenta. Well, that doesn't belong there. You take a look at the baby's first poop, right? The meconium. And plastics are in the first poop. Plastics are in breast milk as well.
That's the medical way to put it, right, Dr. Nick?
The poop?
The first poop?
The first poop.
Yes,
meconium,
right.
The black thing.
But it does illustrate a pretty interesting point, because if it's in the baby's first, elimination or whatever, it's in the mother.
Yeah.
And it was in the mother, and it was being exposed to that all throughout the pregnancy.
Right.
Which is, that's obviously a little unsettling.
Right. The other interesting part, too, I always find fascinating is that they found plastics in male testes. And it's not just a little bit. It's not just occasionally. It's 100% of males have plastics in their testes.
Yeah,
right?
Let's get men's attention here. Some studies There's a great documentary on Netflix we're going to talk about called The Plastic Detox.
Right.
Some studies showing that it's decreasing the size of genitalia in men,
Right.
in addition to infertility issues.
Right.
So that ought to make every man listening or watching this perk up a little bit,
Right.
pay attention.
True.
Another good reason to try and maybe rid yourself of these things inside your body. That's a tremendous problem, though.
It is.
If that is in fact happening, it's a tremendous problem.
It is. So the interesting thing about that is that, in biology, very few things are 100%. I mean, if I take a medicine, right, it's going to work in me. Is it going to work in you? Maybe, maybe not. So, that's true biology. Nothing in biology is 100%. But when 100% of men tested have plastics in their testes, so that's weird. That's just off the chart.
That's a little weird.
Yeah,
A little
very weird. The other interesting thing I didn't have a chance to mention yet is that it's not necessarily the dose, but it's really the size.
Well, it matters.
Right. So what I mean by that is that, if you swallow, let's say, 100 micron plastic spheres, right? In all likelihood, that it will be eliminated from your body. However, if you take that same 100 micron size and make it into nano size, 10 to the minus 9 meters, that's going to be absorbed in your body. So the same amount is important, but what's more important then is the size of the particles, because the smaller the size, the easier it penetrates into the rest of your body. So there's microplastics and there's nanoplastics.
Dr. Nick, your biography is stellar. Behind you on the shelf, Miracle to Menace, your book, How Plastics Rewrote Human History. You authored that with your wife. She was going to be with us, but, like you said, you're a little busy these days. You also have 3 children, and you're potentially changing the world. So, of course we understand here on Off the Set.
Right.
Don't worry about that, Dr. Nick. But your biography, your medical background rooted in a lot of clinical practice, surgical innovation, and translational biotechnology. Beyond your clinical work, Dr. Nick here, prolific researcher, co-inventor on more than 50 patents.
Yeah.
So your most recent work is developing the QI-601 microplastic detox cleanser for civilian use. We're going to get into that. That is the potential solution, getting these microplastics in your stomach to bind together and then out of your body.
Right. You get rid of it naturally.
Naturally.
Right.
Like a baby's first.
Meconium.
Just like that. Pill form.
It is.
Very easy.
Looking back on it, the road was actually very simple and pretty straightforward, but there were a lot of twists and turns, so a lot of pathways. And I'll tell you that our work first started off with understanding how bacteria can work to our benefit, looking at the human microbiome. It's the bacteria that are on us and in us, and it's doing something beneficial to us, And our job at Quorum Innovations was to figure out who's there, bacteria-wise, what are they doing, and then finally, how are they doing it, right? And then, so we figured out that bacteria are good for us, and we were going around the world literally giving talks in London and Boston, and the Department of Defense identified us as being a potential solution, an interesting concept. So DARPA got a hold of us. DARPA stands for Department Defense Advanced Research Projects Agency. And they said, we really like your ideas, especially that bacteria can live on surfaces, human surfaces, and provide barrier protection. That's the key. So they engaged in us, and we were commissioned and got a couple grants from them to develop barrier protection for the warfighter against chem bio threats. Okay? So again, the idea is that you have good bacteria lining surfaces, particularly your eyes, your gut, your lungs, and it can act as a barrier protection. These bacteria can absorb these chemical and biological threats that the warfighters are exposed to. Okay, so barrier protection, fine. And then about a year ago, my son was doing an experiment in high school where he was feeding nanoplastics to these little tiny worms, C. elegans worms, nanoplastics, and the worms were not happy. They were dying, they were curling up, and they were not happy. The plastics causes too much inflammation for these worms to live. And I was thinking about it. It's like, hey, wait a minute. These nanoplastics that my son's feeding to these worms
is killing them,
and it's a barrier problem because the plastics are getting into the worm guts. And if you actually had a barrier to stop the plastics from getting into the worms,
they wouldn't die.
And I was thinking, wait a minute. We're actually doing something already with DARPA developing barrier protection. And it's like, we might have an answer here. So then we did one experiment and a couple more, and I have a really interesting slide of my other son, Julian, who did an experiment with the green test tubes.
Sure. Let me hand those over to you, Doc.
All right, good. Yeah.
Yeah, sure.
One son, Phineas, did the worm experiment in high school, and then my other son, Julian, did this experiment looking at then nanoplastics. And so there are two test tubes here, and we have green dyed nanoplastics, right? So they're too small to see by the eye. Two test tubes treat exactly the same, except one test tube has this biofilm bacterium. And
explain the difference between the two, like what we're seeing. It's like conglomerated in the bottom of the test tube.
Yeah, absolutely, yeah. So one test tube is cleared of the green nanoplastics over here.
It's cleared of it.
Yeah, and it's binding then the green nanoplastic to the bottom. It binds it up, right? And the other test tube, which does not have this biofilm bacterium, postbiotic, the nanoplastics are still floating around. So this is one of the first experiments that we thought that, hey, wait a minute, we might actually have something here that binds then plastics. All right.
Well, you sent me a video with the test tubes. Do you want to see
did.
this thing in action?
Yeah.
All right, let's take a look.
So both test tubes have red nanoplastics. Okay. Nanoplastics, again, for the order, it's a 100 nanometer nanoplastics. You cannot see this with an eye. So a 100 nanometer nanoplastics are, probably have like 10,000 of them together end to end to make up the diameter of a human hair. That's how small it is. So both test tubes have red nanoplastics. One test tube has this postbiotic biofilm bacterium. And you can see, it's a time elapse, and you can see that one test tube, it's clearing the red over a course of about 5-10 minutes. And it's actually pulling down the red nanoplastics to the bottom. And that's exactly what this postbiotic biofilm bacterium does. It sucks the nanoplastics right down to it.
Unmistakable.
Makes it into a larger agglomerate so your body can't absorb it. Now, your body does have some natural elimination mechanisms to get rid of plastics. If it got in there, there's also ways it can get out. But if there's too much of a concentration going in, then there's no way that you can get rid of it.
Let's talk a little bit about the plastic detox documentary on Netflix.
Yeah.
You recommended that I watch that,
Right.
and I'm glad you did.
Right.
So the idea is, and it's on Netflix right now, and I'm going to give away the ending, the hook, but it's important for our conversation that I do that.
Yeah.
Okay, so this follows Shanna Swan, National Academy of Sciences researcher,
Yeah.
and she follows 4 different couples who are having problems conceiving.
Yeah.
A lot of issues conceiving, miscarriages, just not getting pregnant, whatever. And she puts them on a 90-day plastic detox to try and avoid as much plastic as they possibly can. Now, one of the most compelling parts of this whole feature for me was when they start talking about all the things in your home that are made of plastic. Linings of soda cans, seltzer cans, it's plastic inside there. Right? Our clothes, you mentioned, heating food in a plastic container being chief among some of the worst things you can do as far as getting those microplastics inside something you're about to consume and put right into your body.
Yeah.
She puts them on a detox to avoid as much as she can. Now, she's watching something called your BFA level.
Right.
Do you want to explain to me what BFAs are and the level that she's discussing? Because she does tests, and she is looking at each couple's level of this, the level of micro nanoplastics in their bodies, essentially, right?
Tangentially. So, there are the forever chemicals that travel along with these micro nanoplastics, okay? It's actually quite difficult to measure the plastics, and that's one of the part of the studies that's coming out of RFK and HHS. How do you actually measure plastics? But the thing is that all these other forever chemicals travel along with the microplastics, okay?
So if there's an increase in those forever chemicals, we can go with the assumption that there's a lot of stuff in there that shouldn't be there, notably plastics.
Right, traveling along with the plastics.
Gotcha.
And so it is known that these other forever chemicals are related then to infertility. And so you can measure those. There's ways to actually measure those forever chemicals, right? So that's the assumption right there.
That's the assumption.
Decreasing the amount of plastic exposure, ergo, then you also decrease the amount of absorption of these forever chemicals. And then, fortunately, these people actually got pregnant.
They check in. Well, they check in 45 days, and I gotta believe, as somebody who's worked with a lot of video editing and putting pieces together, that's when they knew they had something. Because the drop in the BFA levels just at 45 days with these couples, because they were religiously trying to detox this, they get plastics out of their lives as much as possible, changing their dental floss,
right,
down to changing the damn dental floss.
Right.
At 45 days, they noticed significant reductions. At 90 days, we start getting positive pregnancy tests.
Yeah.
And here's the hook.
Right.
All 4 couples successfully conceived healthy babies at the end of this documentary.
Right.
Ooh,
Right.
that's a good selling point, isn't it?
That works.
That works.
To prove it is, that's the reason why you have actually in-depth studies, right? So maybe it's just 4 people. Maybe just the fact that they had attention directed to them, things just work better. Yeah, you have no idea.
Who knows?
Right. But it is certainly convincing, and there's the scientific evidence is sort of lining up. Right? So the pieces of the puzzle lining up, and the connected dots right here is getting closer and closer.
Let's talk about 601 real quickly.
Yeah.
This is the world's first microplastic detox cleanser, developed in pill form.
Yes.
Yeah.
So yeah, 601, which is that's the active ingredient. It's called My Gut Guardian, powered by QI 601, and it really did. It took us about 601 tries to sort of get the experiments right and to get this produced properly.
Human trials.
Yeah, we have a human trial. So this is the first human clinical trial looking at plastics, and is there technology that can actually bind plastics in people? So we had someone chew a piece of gum for like 1 minute, 2 minutes, 5 minutes, 10 minutes, and they would spit out on a slide, actually into a test tube, and then we put it onto a slide, and then we would stain it. Right? And so that red thing right there is a 56 micron plastic particle inside gum, right? So we didn't do anything dangerous. We said, hey, chew this piece of gum, spit it out, and then we just stain the spit right there, and that's plastic right there.
Jeez.
And then what we did, we had the same person chew it, now with a little bit of QI 601, My Gut Guardian. So you can see right here, a couple things happened.
Sure.
One is that there's still a red plastic particle right there.
See
right?
it?
It's stained with now red. But then you see this smudgy thing that's right around it. And what that is that's QI 601, that it's actually bound to the plastic particle right there.
It's captured it.
It's captured it. And so this is a light microscopy, and you'll see this is all QI 601, and then it's surrounding this little tiny plastic particle that is that. So that right there, that red thing, is that black and white photograph right there.
Unbelievable.
Yeah. So that's that. And the important part about it is that 2 things. This isn't a real person. This is in vivo testing, right? And this is the first technology it's ever demonstrated to bind plastics in people. And then, as we mentioned earlier, subsequently we took that same plastic particle with 601, put it in stomach fluid, made sure that it didn't let go of the plastic, put it in intestinal fluid, didn't let go of the plastic. And so from beginning to end, it held on to the plastic by, I think the numbers are 92 to 98%. Yeah.
And that's in different, like you mentioned, it's in different scenarios. It's still effective.
Yeah.
And I'm sure were you surprised by that? I mean, that's another question too. What was the most surprising part to you throughout the entire process? What were the big shocking moments? You probably couldn't believe it was that effective, right? Can we start there? Or were you confident it was going to be?
Well, it was a 50-50 shot, to be honest with you.
I guess a lot of things in medicine are. Yeah.
Yeah, you have an idea. It's like, well, this should work. And you know what? If it doesn't work, you figure out a solution around it. It's like, what do we need to do to make this more effective? How do we make it, work better? That's when you have failures, it's really a sliver of success you're looking for. Like, what do you need to do next? That wasn't the most shocking part, though. There was another experiment I haven't even told you about that was, to my mind, more shocking. We grew up human colon cells on a petri dish, and then we applied these green nanoplastic particles on top to these human colon cells. And we demonstrated that these little tiny green nanoplastic particles went into the cell and localized right around the nucleus, the sort of the brains of the cell, sort of stuck right around the nucleus of the cell. It was bizarre and scary.
The plastic particles did that?
Yep.
They went inside the cell.
Inside the cell. So the most shocking part is that these little tiny nanoplastics, which you cannot see under a microscope, they're too small, went into the cell. And I was looking at it, it's like, hey, wait a minute. It makes these little tiny, like almost like Christmas balls in a way, or little tiny green lights. And it went into the cell, and I'm looking under the fluorescent microscope. It's like these nanoplastic particles are too small to see under a microscope, and yet they were actually coalescing into a ball. And what it told me is that there's some mechanism on the outside part of the cell that's grabbing all these plastics outside the cell, taking it, making it into what they call an endosome. So it coalesces them, makes it into a ball, brings it inside the cell because it's trying to chew it up. And it coalesced it to make it actually visual, and it localized right around the nucleus of the cell. That was bizarre. So we actually saw the active process of nanoplastics outside a human colon cell, drawing it into the cell and right around the nucleus. And then, of course, the obvious experiment is that we put the 601 on the outside of the human colon cell, and it drew it from outside the cell, and it pulled it out.
It pulled it out.
It decreased the concentration inside the cell, and that's phenomenal.
Can we backtrack just 2 steps?
Yeah.
Why do you think the plastic would go all the way inside that thing?
It's trying to detox it. So there's a well-known established mechanism of taking contaminants that are outside the cell. It draws it in. It's called an endosome.
Yeah.
It takes this endosome, fuses it with a lysosome, right? It's the lyse stuff, all these digestive enzymes, tries to chew it up, but guess what? The body is not made to chew up plastics.
It can't do it.
Can't do it. And then finally, when it tries to chew it up, and it actually starts exposing it to the outside exosomes. It gets rid of it. Tries to. But the thing is, if there's too much on the outside, then it keeps on building up on the inside. You just can't keep up with the flow.
What's the long-term effect on the cell with a piece of nanoplastic inside of it? Would it shut it down eventually? Would it kill the cell?
Don't know the answer to that. I know that there are some ongoing studies looking at mitochondria, for example, and how mitochondria are not happy when there's plastics around them. But the long-term effect, no one knows. I just don't know. Nobody knows yet. Yeah. So.
Wow. All right. Well, I mentioned that you and your wife have been working with the Health and Human Services Administration, Robert F. Kennedy Jr. and everything.
Right.
This is something that was in one of his MAHA reports,
correct,
identifying microplastics. Can you just talk to me a little bit about what you guys are doing there?
Quorum attended the STOMP initiation program, and a couple things happened over there. They laid out the program, and it's very ambitious, and it's also very thorough, and I applaud them for that. It's a subdivision of ARPA-H, so Advanced Research Projects Agency for Health. Now, they have a couple different objectives, and the first objective is to try and understand how to measure plastics, because no one knows how to do it yet, right? So you got to be able to measure this type of plastic or that type of plastic, and so essentially for the first year, they're going to try and understand how do you measure this thing. And so their objective is to say, we want to be able to measure plastics in people, in body fluid, for $50 and under 15 minutes. So that's ambitious, right? So they're going to try and figure out how do you actually measure it, because you need a way to measure it in order to figure out if your technology is working or not. The second part, in the second year essentially, is going to be, okay, now that we can measure it, how much does it take? It's the who, what, when, where, and why of plastics. What kind of plastics are getting into us? How are they getting into us? Where are they localizing? And what kind of problems are they causing? And then how do you prove it? That's the second year. So the first year, try and measure it. Second year, where's it going? Where's it going? And then potentially what problems is it causing? And then finally, the third year is that how do you mitigate it, right? And so that's where we are going to be fitting in.
You're part of the mitigation.
We're part of the mitigation, but that's a little bit further down the road. And so we are going to be focusing on the mitigation part right now. And that's where our focus is right now.
Wow. So 601, it is currently available. It is being sold. You have FDA approval on this. How soon till this is a regular part of our medicine cabinets?
Yeah. So the bacterium that is the source for 601, we submitted to the FDA, I don't know, maybe like 4 or 5 years ago. And that bacterium, so we submitted all the evidence for it. The genetic composition, obviously the source of the bacterium is just, you can't get much better than the source of bacterium as being coming from breast milk, right?
Pretty reliable source.
Pretty reliable, very safe. So we submitted all to the FDA, and they determined this particular bacterium is safe, right? So that's the source of the bacterium. And then we inactivated it, okay, to make it so it's reproducible in people. So that's the FDA approval part. As far as the FDA goes, because we're not making disease claims, right? Then we are not considered a drug. So we are a nutritional supplement. We are not making any drug claims whatsoever. And so it is available.
It's available.
Yeah.
You want to tell our audience where they can pick this up?
Sure. Yeah. So the availability is under My Gut Guardian. And so it's online, and we are producing sufficient quantities.
Wow. Well,
yeah.
Congratulations. It's
Thank you.
It truly is a breakthrough.
Yeah.
It truly is a breakthrough.
Right.
Just to final takeaways here. This is something that was not on my radar before you contacted me.
Really?
And you were surprised by that.
Yeah.
And you had asked me, you said, well, what about other local media, and where are we with addressing issues with microplastics? And I've been an anchor for a long time.
Yeah.
I've gone through a lot of news cycles.
Yeah.
And yes, it has been in some national reporting. I don't find it very consistent on the local level and local news.
Right.
I've hardly ever seen it.
Mm.
In fact, I couldn't tell you one microplastics warning story or anything that I've ever come across or has come down the pipeline from our government, come down the pipeline from medical professionals to warn our audience about, which is why I was really into the opportunity of getting you up here to at least put something down and tell people, hey, there are issues here. We can't identify exactly what they are. Infertility, anecdotal evidence is showing us that there's a strong connection there.
Right.
I mentioned just other effects to your genetics. Of course, I mentioned smaller genitalia in men, which should get everyone's attention.
Right.
Right?
Right.
So it's a problem.
Yeah.
And it's also everywhere. I just can't say that enough. Look around your home right now.
Yeah.
Look at all the places there are plastics.
Right.
And think about all the opportunities you have on a daily basis to ingest this stuff.
I mean, look at it
It's
in
scary.
this room.
Look at it in this room.
Yeah.
Yep. I talked about your bottle. There's plastics on that audio board. There's plastics around these microphone arms. There's plastics around the cell phone case that I have. There's plastics in this pen. I told you I warmed up my breakfast this morning in a glass bowl with a stupid plastic lid.
Right.
Okay? Now, plastics were invented. When they were invented, they had incredible uses.
Oh, it was a miracle.
It was a miracle, which is the title of your book, Miracle to Menace.
Right.
But, science evolves, right? Things change over time. And I think we're at that precipice where we need to find solutions like the one you've presented. But long term, don't you think we need to move in a direction where there's just simply less plastic produced? Isn't that the ultimate goal here?
For sure. So there's two problems to that. One is that, we talked about earlier, there's roughly 400 million metric tons produced per year. And that's not going anywhere.
No.
So, and that's going to be recycled and recycled and recycled all the way from the little tiny, plankton that's in the ocean to the fertilizer that we're using for our food. So that's one issue, right? How do you deal with such an accumulation of plastic? In fact, when you define geological terms, there's the Paleolithic period. This is called the Pleistocene era, because plastics are they're leaving their geological footprint on the earth, right? So there's one issue is how do you deal with the accumulation, right? That's not going anywhere.
Mm-hmm.
And then second, how do you start supplementing or changing these products that we have and use, all the way from the plastic syringes to the IV tubing that we have in hospitals.
In hospitals,
right?
Yeah.
To you keep on going down the line. You go to the little plastic binkies. I have 3 children, right? They all had the plastic binky, right? To the plastic bottles that we used to put in the microwave and warm up the milk
How about that?
for them. And it just goes on and on. To, as I said earlier, the gum. Right? We all chew gum. It's there too.
Every day, Dr. Nick. Every day.
So-
let me ask you this.
Yeah.
How important do you think it is that, at least at a young age, we're changing the way we educate our young minds about potential dangers with plastic?
Yeah.
For example, thinking back when I was in elementary school and learning about plastics, the only warning we ever got was don't throw them in the ocean because they could get stuck around a fish's neck
Right.
or a duck's neck
Right.
or something, right?
Yeah.
That was the warning.
Right.
Wow, times have changed, huh?
Right. Oh, for sure.
But do you think it's important that in our education system too, we start letting the young people know, hey, there's some problems related to this potentially?
Yeah. I think people are more aware of it than we give them credit for, honestly. So last evening we were at a restaurant, and our waitress was, she was like 21 years old. And I asked her, I said, hey, do you ever think about microplastics? And she said, no, not really. And then I started asking a little bit more. It's like, well, do you cook with, do you heat up your food in Tupperware? And she said, no, that's not a good idea because there's lots of chemicals inside there that get that volatilized. I don't want to eat that. So,
It's a good start.
Yeah, the more I talked to her, the more I realized the more that she realized, I really am aware of this. But initially, she was not. And so I think there is an undercurrent that people are realizing that there are toxins that are out there, and they're best served to avoid them whenever possible. But the problem is that right now it's just not possible. How are you going to not drink plastic out of a soda bottle, right? It's everywhere.
I know.
So there are other solutions, and it needs to be a combination of both
Detoxing a little bit.
detoxing with what we have to offer, and then also to decreasing the amount and its availability, and to finding other materials. Clothing. Oh my gosh.
Yeah.
Clothing. Actually, I was at a store yesterday, and it said made with recycled plastic. I'm like, good, right? You put that in your body, and you get it all nice and hot. Exercise clothing,
Sure.
and then just really work to absorb it. Oh, another one, Crocs. Yeah. So these little plastic shoes, right?
Yep.
So what they do is that in order to make it softer, they put some phthalates inside there to make it bendable. And then you put your foot inside there, get it nice and warm, a little bit of moisture inside there, and it works as an extra absorbent for these other forever chemicals that are included then in the plastics. So yeah, there needs to be other solutions, for sure.
And a daily supplement.
Yeah.
Probably not a bad idea. The product, again, is QI601. It is available. Again, the site to check that out. Go ahead, Dr. Nick.
My Gut Guardian.
Wow. It's hard to leave this on a real poignant note with all the things we've discussed. But Dr. Nick, years and years of work here, you and your wife with this breakthrough, congratulations on that. I wish you the best of luck and the most success. And I really feel like your work is in the right place. It has the right heart behind it, just to help people and avoid these types of complications that more and more anecdotally we're seeing are big issues.
Thank you.
Thank you, Dr. Nick. Appreciate your time.
My pleasure.
All right.
My pleasure. Thank you for having me.